Well, we have a relatively small group today, in part because this is his second or third lecture we're giving on this topic in the area. He already spoke at UMass before, so some people thought it's exactly the same, but I think they're missing it. Because what he had a very different way of presenting to them, especially about this Samudra Manthan. And of course, some of you already know Professor Amit Tondon. He's originally from India, you can imagine. Actually, his father and I went to the same high school. So, and he has been to my hometown, although he was born there. His father was in service, so he moved around all over India. But he actually is very prominent physicist, particularly about this oceanography. And in that, this prediction of monsoons and different kind of models, he is a world leader, and he's leading an effort of Indo-American scientists. So this is the Indo-US program funded by the National Science Foundation, which I'm assuming that they are making some headway. I don't know really. I mean, I would like them to predict the weather here first before they go to the monsoon. But I think the monsoon prediction has more value because I think a lot of lives depend on that. So he's going to tell interweave the story of what is something in Indian mythology and to science and how that can be used to help people, particularly farming. I mean, we all need farming because without food we cannot live. And then also to how this is related to culture, because large part of culture here as well. Even here, mostly people complain about whether in India people actually celebrate. So I'm really looking forward to that story of Samudra Manthan and monsoon prediction and Indian. Thank you.
Thank you, everyone. I would like this to be more of a dialogue because the series is called Samvad, and I came to the last one in the series where Dr. Singh was talking about his experience in the 50,000. So I will do this in the same way, and so please feel free to ask questions and repeat. And as Dr. Singh mentioned, the prediction on sort of 1 to 3 days time scale is actually quite good. I can tell you fairly well what is going to happen in the next 24 to 48 hours, maybe even 72 hours. But it doesn't matter where you are in the world. The prediction of about 7 to 10 day time scale begins to get really bad. And beyond 10 day time scale, there is almost no predictability in terms of the details of the weather that we like to have. Even though if you go to AccuWeather or Wonderground or any of your favorite sites, they will tell you weather prediction 6 months in advance. But what they're mainly doing is just running some model and letting you know what the range of the model is. But the accuracy of that forecast gets really bad after 7 to 10 days. 1 to 3 days we have fairly reasonable accuracy. It has gotten better in the last 20 years. But in order for us to go to the next step, and I think that is really the important step, we have to realize that the whole world is connected. So if we want to really be able to predict weathers for 7 to 10 days in advance, then the first realization we have to have is that the tropics, the weather in the tropics governs our weather 10 days in advance. Our weather now has a link to the tropics 10 days in advance. So really when we get into the predictability of 7 to 10 day time scale, we have to think of the whole Earth as a family. So that sort of brings me to the Indian concept of forgetting the exact place. Vasudhaiva Kutumbakam. So Vasudha is the Earth, and Vasudhaiva basically means Earth is a family. So the entire Earth and the living beings are of Earth. So with that introduction, I want to come to an ancient story from India, which is called Samudra Manthan. Samudra is the Indian word, is the Sanskrit word for ocean. Manthan is essentially means churning the ocean. So in some ways there are parallels between churning of the ocean, which is the churning of the metaphysical ocean, or churning of the spiritual ocean which is within us, and churning of the physical ocean which happens, of course, in outside. So these are some famous reliefs. This is from Angkor Wat in Cambodia. This is another one which is shown more in detail. Essentially, what is shown is a Mount Meru, which is being used as a way to as a stick, almost like a mountain being used as a stick to churn the ocean. And there is a snake here, which on one hand is being pulled and pushed by what do we call the devas or the suras, and on the other side are the asuras. And they are both trying to churn the ocean to get something out of it. And in this case, the story goes, and there's Vishnu who's helping them out, but Vishnu also plays a very important role later on, and as does Shiva. So as they churn the ocean, the story goes, a number of things come up. And some of them are very, very beneficial, but before any of the beneficial things come out, comes the most poisonous thing of all, which is called halaha, which is the most poisonous toxin ever. And so then that you know more about that than I do.
We should find that out.
So we should find out whether the halal that Shivji drank.
What about the line?
It may very well be. It may very well be some concentrated form of botulinum that he had to drink.
Yeah.
But then his wife, as or so the story goes, Parvati doesn't let the poison go below his neck, so into his body, and so that's why he has a blue spot here. He's often called Neelkant because, but he's the only one, the trinity of the Brahma, Vishnu, and Mahesh, who's able to sort of save the world by taking that over. So there are many levels of this story. The level at which I'm telling you this story is perhaps more suitable for kindergartners and people from grade 1 to 5. But there's also a different level of this story, because we can translate this story to ourselves. So we have the suras and asuras within us. We have the ocean within us too. And we have to churn the ocean to basically churn our conscience to get our experience about it. So one of the symbolism we can think about is the human consciousness as the entire ocean. And this level of consciousness has lots of goods and bads, and how do we churn to get it out? The snake, which is being pulled by the suras and asuras, can symbolize what our desires are, and devas are the sort of the good qualities, and the asuras are the bad qualities. So essentially, our desires can have to be controlled in order, and we have to realize the good and the bad both of us. But to go to the next level, we have to churn the ocean, we have to churn our human consciousness with our concentration, which is what the mountain is symbolizing, which can be negatively affected at some time. So in the lower version of the story, or in the elementary school version of the story, it turns out that the mountain needs a support in order for it to churn. So then this is where I think it's Vishnu avatar. I think it's the second avatar. I forget which exact number, but he comes as a turtle, and then withdraws in a turtle, and the mountain then goes on the top of the turtle's shell, and that's how the story proceeds, in order to churn the ocean and get the good and the bad out. So in this case, the turtle essentially represents that we have to withdraw from our senses like the turtle into the shell, and be able to support our concentration to get to the next level. When we do that, though, we go through, we have to get past our pain and suffering. So the poison that we are talking about at this level could be pain and suffering, and perhaps some of the grief that we go through, and some of the pain that we go through is could be as painful as any of the physical pains that we go through. For example, when you're subject to toxins. And then after this out comes all kinds of jewels out of the ocean, and then there is a long list of different things, and they all have different properties. They can all be used for different materials. One of the jewels that I remember very clearly is the Kamhin, which is the cow that essentially gives everything. So that's I think where some of the holy cow comes from, is from Kamhin. And that again, there's a symbolic meaning to it. It's not just physical. Finally, what the Devas and the Asuras in the story are after is Amrit, which is the nectar of that allows one to get the eternal bliss, and that's described as them. But there again is a different meaning to the Amrit and the eternal bliss, and different people may find it at different levels. So for me, the pursuit of knowledge has a parallel to the pursuit of Amrit. Essentially, there are many different kinds of knowledge, there are many different levels of knowledge, and pursuing this project on a physical level, but also pursuing this project on a spiritual level, has been very revealing in terms of learning as much about the external ocean as about the internal ocean amongst ourselves. This is sort of the spiritual backdrop to the project. So now I'll bring you back into the physical world, and let's go back into the physical world just for a second. So this is a picture from about 2.5 weeks ago. And Rajkumar was in Jamshedpur not long ago. Maybe he was there in India about a minute. And most of India was in grips of temperatures which are higher than 43 degrees Celsius. There is one place here in Odisha called Titlagarh, which is at 46 degrees Celsius. Now 45 Celsius roughly corresponds to about 115 Fahrenheit. Excruciating heat. And this is sort of the pre-monsoon weather in India. Normally these kind of temperatures don't come so early. You may see a heat wave in May or June, but this is early. There's another, I want to bring us back to the United States too for a minute, because we go through heat waves in this region too. A large part of Midwest, there'll be some heat wave-like conditions, and those can really put children and elderly and other populations in danger, and we have to be, that we already know about the drought that's going on in California and parts of the US right now. What if we actually wanted to have some prediction of when the next heat wave will arrive? So I just told you at the beginning of the talk that if we want to know the weather 7 to 10 days from now, there's almost no predictability. We can't really predict with any accuracy. But there is a paper that came out. This is not my paper. This is somebody else's research. This paper just came out in Nature in March this year, which basically says that the memory of these heat waves actually resides in the ocean. So that's not, as an oceanographer, that's not surprising to me, because the ocean holds, just the top centimeter of the ocean holds as much heat as pretty much the top 100 meters of the atmosphere, and the top meter of the ocean holds as much heat as the entire atmosphere above us, all the way up to about 25-30 kilometers, depending on how you define the edge of the atmosphere. So a lot of the heat actually is contained in the ocean, and if we understand the ocean much better, then we can begin to understand the communication between the ocean and the atmosphere. We can begin to understand on longer time scales how the weather is going to behave wherever we are. So in this case, we are finding a very clear connection that if we look at something which is called the Pacific extreme pattern, then there are very warm temperatures here. Essentially, this pattern shifts over the central United States. I'm making the story somewhat simpler, but about 49 to 50 days in advance, about 7 weeks in advance, you have some ability to say where the heat waves are. Imagine if that were possible for India. That work hasn't been done yet, but I'm very interested in doing something like that on the heat side. But for this project, this was mainly based on trying to find out what is the role that the oceans play in setting up the monsoon in the conditions. So there is a list of names here. This includes both scientists from India. It includes scientists. All the senior scientists are listed here. They are listed from both India and the United States. This does not list, unfortunately, their graduate students, their postdocs, and other people who are working in their labs. Overall, we have about 50 to 60 people who are working from both the United States and India. The Indian scientists who are working on this joint project are funded by the Ministry of Earth Sciences in India. The US scientists are supported by the Office of Naval Research, and I'm one of the 4 or 5 chief scientists for this project. Devasi Sengupta and Ravi Chandran are the US leads, and then there are 4 or 5 of us from the US who are basically in charge of this science portion. So I just wanted to show you 2 pictures here. Again, these are from models. This is from an atmospheric model which is showing the monsoon winds in the summer. So in summer, the winds, particularly in the Bay of Bengal, are going from the southwest to the northeast. So it's very peculiar. The winds actually go this way, but the monsoon, the rain bands actually travel this way. And that's what brings most of the rain to central. What is shown in the lower plot here is something about the ocean. So here I'm showing you a snapshot of the atmosphere. Here I'm showing you a snapshot of the ocean. And this is basically showing the eddies in the ocean. These are, think of these as large whirling masses of water. This distance here is about 3,000 kilometers or about 2,000 miles. This distance here is about 3,000 kilometers or about 2,000 miles as well. So think of this as a box which is about 2,000 miles by 2,000 miles. We could fit more than Texas there. And these eddies may be as large as 500 kilometers or so in diameter. It turns out that they play an important role in storing the heat of the ocean and then releasing it at appropriate times, which affects the monsoons. So this is not even written up yet. Yes.
What about the moon? You know, considered the moon and the planets and their effect on the ocean.
So the biggest effect that the moon has on the planets is by the tides that it creates. So there are lunar tides, there are semi-diurnal tides, there are diurnal tides because of the sun, and there are also the biggest signal in this basin is because of the semi-diurnal tides because of the moon. So the planets don't really affect the monsoons that much, but what really does affect is the gravitational pull of the moon on the water. But that effect is actually very predictable. That effect occurs very regularly. We know exactly the time period at which it affects, the interesting thing is, though, what happens to those tides when they rub against mountains in the ocean or when they go against the sides. So they lead to something called mixing of the ocean. They help churn the ocean. So this is where the churning of the ocean is coming from. So there are multiple things that churn the ocean. One effect is coming from the tides, and the tides themselves, you've heard of high tide and low tide, and we can go and look up the tide tables here. But remember how predictable the tide is. I can actually look up when the high tide is going to be in a particular harbor, 25 days from now, or 3 months from now, or even 6 months from now. And those predictions would be entirely correct. The only thing that would happen is that the weather may cause that tidal elevation to be a bit higher or a bit lower, depending on whether there was a hurricane in the region or whether there was a big storm in the region. But we can actually predict the tides very well, months to years or however much in advance. So that part of the moon's effect on the ocean we know very well. The part that we know less about is when it begins to interact with what is happening in the atmosphere and when it leads to churning near topography.
Because I know that someone who did fishing once told me that whenever there's a full moon, you have more cooler weather or extreme weather.
that's a bit of a stretch. I think what happens is whenever, so again the spring tide, neap tide, and full moon. So there is an effect of full moon versus new moon on tides. But there is a certain delay to it as well because of the way the ocean reacts to the gravitational pull of the moon. The feedback is more from the winds and the hurricanes. Basically, if there was going to be a high tide anyway, and now if you have a storm, the tide, or if there was going to be a high tide anyway, but now there's a storm surge because of a hurricane, then that storm surge can be much more powerful. So in that sense, yes. But that part of the tides is actually predictable. The part that is less predictable is where are the ocean eddies going to be, how do they form, how much heat do they trap, and when do they realize that they should now release the heat to the atmospheric engine, which will now take this take this moisture and take it to the land. So in Indian literature, for example, there are entire epics have been written which sort of describe the clouds and how they come and how they bring in rain. Poets do it. Music is full of all kinds of references to the monsoon because it's very closely linked with agriculture. It's very closely linked with people's lives. So I will show you this map just for a little bit. This map is basically saying something about how well we can predict rain throughout the world. And it's saying that in the equatorial Pacific, which is where El Nino and La Nina occurs, we can actually now do quite a good job of predicting where the rain is. When we go to this part of the world, however, on this part of the Pacific, this part of the northern Indian Ocean, even this other part of the Indian Ocean, our predictability is very low. We do not have any measure, any skill. These are different kinds of models. These are there's the National Center for Environmental Protection. This is the US model. This is the Singapore model. This is a Japanese model. This is multi-model ensembles. All of these models have very high levels of predictability in this region. All of these same globally coupled models have almost no predictability or near zero predictability when it comes to predicting rain in this region. So this is something that affects this region hugely. It affects India, it affects China, it affects anybody who's living in this part of the world. It also affects any ships that are plying in the region. It affects any kind of trade that is happening through this region. The monsoon, it turns out, the way we think of monsoon in our geography textbooks looks something like this. We say, in summer the monsoons do this, and I'm as much guilty of this as anybody else. The winds are really in this direction, and they are nearly constant. This is the part of this is the region that gets most of its rain. In the winter, the winds reverse direction, and it's South India and Sri Lanka that gets most of its rain during the winter monsoon. But this picture is only telling you as if what is happening during the season, the summer monsoon season and winter monsoon season. But the real rain does not happen in a steady form during the month. It happens in cases where there may be large bouts of rain, up to a few inches, and then there may be periods of rain where there is almost no rain at all, and then another 2 weeks later there may be another big batch of rain. Then there may be for 4 or 5 days there's no rain. Then you get another batch of rain for 4 or 5 days. And so what is shown in the background here is the average of all of this symbol, which is how the monsoon behaves, which is how we think of monsoon. But monsoon actually comes in a series of rain events. You get a big rain event, and then it doesn't rain for 7 to 10 days. Then you get another rain event, and then it doesn't rain for 7 to 10 days. So to do this right, we have to be able to tell the farmers, okay, now there's not going to be any rain for 7 to 10 days, so they plan accordingly. Or whether the next rain event will now come in another 10 days, and for how long will it last? So that is the predictability that no model in the world can actually make at this point. And we think that has something to do with how the ocean sets up the conditions in the Bay of Bengal. So this is where we went. We said we have to go to the Bay of Bengal because this is a region which is very fresh because of all the rivers that empty into this. You know, this is Ganga and then Iravati is here. There are lots of rains. There are lots of rivers that come on this side as well. So the combination of rivers and rain here makes this basin much less salty compared to the Arabian Sea, which is much more salty. And so and if you look at the last 30 years of where the storm systems take birth and how they bring rain over to India, you can see that there are very few storms in the Arabian Sea, but there are many more storms that take birth on the Bay of Bengal side. So that creates a lot of rain coming in from the Bay of Bengal. So this is why we got funded, or our teams got funded, to go to the Indian Ocean and to look at the Bay of Bengal. Because it turns out, as I said before, the models in this space are really bad because we don't understand how the atmosphere and the ocean talk to each other, and we don't understand how the upper ocean is storing heat, so that our monsoon predictions are actually quite wrong. So I started working on the steaming effort about 2009, 2010, and it took us about 3 or 4 years to get to the point that we could actually all go on a ship and work together, both on the US ship and on the Indian ship. And there were certainly some challenges. There are geopolitical challenges. It turned out that a US research vessel had never been to an Indian port, especially on the east coast of India. In India, there are multiple ministries that deal with sciences that have to do with the ocean. So there's the Ministry of Earth Sciences, there's the Department of Science and Technology, there's the Indian Space Research Organization, and then it turns out that in order to be able to work with these ministries, you have to have the clearances from the Ministry of External Affairs, Ministry of Home Affairs, and the Coast Guard. So there were something like, so you're really dealing with something like 6 or 7 ministries, plus the science liaison here in the embassy in Washington, D.C. So even though, we started talking to both our US sponsors and to Indian scientists about 2010, but it took us about 3 years to realize what all the constraints were and how to overcome them and how to work together and how to convince all the ministries and all the sponsors, both on both sides, both in the US as well as in India, to say that this was really something for global good and this science is very much needed. It's very much needed for the United States because if we want to be able to figure out what our weather is going to be like 7 to 10 days from now, then we have to understand the weather in the tropics. It is very much in favor of countries like India because their entire economy and life goes around monsoons. So we made lots of progress. We have made lots of progress in the last 6 years now. This program started in 2013, so we actively started taking data in 2013. So I'm showing you 2 pictures here. The one on the left is taken on the Indian research vessel, which is called Sagar Nidhi. So Sagar stands for ocean and Nidhi is really the jewel. So it's the jewel of the sea. And what you're seeing here are both Indian and US scientists standing on the deck of Sagar Nidhi. Sagar Nidhi is a large ship. It is about 100 meters in length. It was originally designed as an oil rigging ship, so it is very, very stable. And what we're seeing here are some advanced instruments. This is called a Lagrangian profiler. This is an ocean glider. Think of both of them as some different variety of ocean robots which can take data in the ocean. And so so India has very capable ship facilities and it has very capable mooring observations, but it did not have any of this expertise with these kind of robots. So one of the things that is happening is that the Indian scientists are getting trained in using these instruments and in getting data from them. And in the next 2 years, in fact, on Tuesday I'm going for Oregon, where a number of Indian scientists are also coming, and we will sit down and begin to look at the data together and analyze it, and then I get back on Saturday. And so we worked with a number of ministries to make this happen. We had exchanges, we had training workshops. So I taught in a training workshop in 2015 summer. I'm again going to India this summer to teach another training workshop, which now, the first one had more to do with the theory, this one has more to do with how do we work with the data we have, how do we analyze the data. The picture on the right actually is taken while we are standing on the US ship, which is called Roger Revell, which is a similar size to the Indian ship. It's also about 100 meters long. And in the back you can see the Indian ship, which is the Sagar Nidhi. So one of the hardest things to do in oceanography is to get what is called ship time. Because ship time is very, very expensive. I mean, these ships are very valuable, they're very useful, but they cost about $100,000 a day to operate because of all the people, the fuel, the captain's salary, the crew, all the scientists. There's a crew of about 20 to 25 people on the ship. There's a science party of about 30 people on the ship. So every minute on the ship is counted for. We try to make sure that we are taking data at all times. We are making as good use of the ship as much as possible. So you can imagine that getting ship time on one ship is hard enough. Getting ship time on two ships is even harder. And then making sure that both the ships are in a similar region so that we can actually work together and make a picture which a one ship by itself will not be able to make gets near impossible. So I'm very, very proud that we were able to do this in August, September of 2015 last year. So there are many institutions in India that are involved. There's ISRO, which is the Indian Space Research Organization. They have a Space Application Center in Ahmedabad, that's part of it. IIT Bhubaneswar, Indian National Center for Ocean Information Services in Hyderabad, also the Tata Institute of Fundamental Research in Hyderabad. There are two institutions in Chennai, IIT Madras and National Institute of Ocean Technology in Chennai. Indian Institute of Science in Bangalore, because that's one of the premier institutions for masters and PhD students in India. So there are 8 or 10 institutions that are involved all around India that are part of this. I should also have put IIT Delhi, because now we also have 2 scientists from IIT Delhi who are working on this. So as I said, we started working together in 2010, and there are many things we did. Some of them happened in the United States, which are in white, and all the things that are in yellow, they happened in India. And there was a whole team of us trying to steer this and make this happen. So I took some of my teaching instruments to India, and then I conducted workshops there. This is a colleague of mine from the University of Washington who went with me, and we had some training workshops for junior scientists in India. Here I am with a bunch of junior scientists, both from India and Sri Lanka, working together on the ship. We also had, for the very first time, we had another kayak, which basically acts like a third ship, because it can also make the similar kinds of measurements of the ocean for predicting monsoon as the ships. So there are many advanced instruments we used. So I just would like to show you this sort of our work in short on Google Earth. So we have the US ship here, Roger Revell and Sagar Nidhi shown here. There's Sagar Nidhi and Roger Revell shown here. And so when we got to one of the big ocean eddies, we wanted to map out how much heat is being trapped in these, which would then, because this heat ultimately fuels the monsoon. One of the things that fuels the monsoon is the heat that it gets from the ocean. Also tropical storms. So here we have the US ship, which is deploying a lot of instruments, about 51 of them. And then here is the Indian ship, which is doing its survey. And then the Indian ship goes and surveys a lot of part of the ocean, and now the US and Indian ship begin to work together. So each one of these lines is about 6 hours long, and so for about once we started working together for a period of about 10 to 11 days, we kept working. So minute after minute, hour after hour. Sometimes you will see this third ship appear. And that is the kayak that I was talking about. That kayak is also very heavily instrumented. we can deploy it from the ship, and there are times when rather than 2 ships, the Indian ship and the US ship, we see 3 ships because the little kayak is also doing its measurements. So, and then meanwhile, all the things that we deployed are all tracking different paths in the ocean, and as they're doing, they are gathering data. They are sending this data to us on the ship via the satellite. There are some of these things that we go back and pick up and bring it back with us. There are others that just freely go into the ocean, and then we don't see them, but as long as they're collecting data, they send us back the data. So there are many first ever things that happened that are good about this project. This was the first ever international collaboration with 2 ships, and both ships doing parallel tracks in order to capture what is happening in the upper ocean. This was the first deployment of the kayak that I showed you. We call it ROS, the remotely operated surface sampler. And this was the first ever when there were 3 platforms, 2 ships, and the ROS doing parallel sections together. This was the first 3-meter deployments in the bay. There's unprecedented amount of historical data set that we have collected as part of Sagar Nidhi and Roger Rivel working together. So this tiny thing was our ship number 3, but we instrumented it very nicely. So I just wanted to show you a little bit of clip of how this ship, this 3rd ship takes data. There's some sound to this. I'll see if we can actually see the sound. So there's a GoPro camera on the kayak. So we are deploying the kayak now from Roger Rivel. Now it will go in actual speed. So now we let it go. It has been given some directions, and so initially we control it by the radio, and then it goes above radio range. Then it gets the instructions from us through some satellite communication and goes to the next phase. So it has some solar cells on the top, so it gets some energy from the sun, some other from the fuel which is on board. And now you can see the US ship is very far ahead of it. It's trying to catch up and take its data. This is now a clip from the ship of the kayak, which is making measurements. So this was the first ever deployment of its kind for measuring the heat in the surface ocean. There is also a mooring that was deployed by the Monsoon Oceanographic Institution for almost a year. This mooring essentially measures the communication between the atmosphere and the ocean, but what you don't see underneath here is also about a long chain, roughly 4 kilometers long, which has lots of instruments on it, which is also taking data. So, and the reason we wanted to use something like this is because it tells us how the atmosphere and the ocean talk to each other for an entire year. So it goes through the summer monsoon, winter monsoon, and in between. Because this is also a place where we don't understand how the atmosphere and the ocean talk to each other. So there are some curves plotted here. What is being plotted in the red is the actual, what is happening. What is being plotted in the black here is the best known model and how that behaves. So even the best known model misses out a lot of things that we are seeing in the red. So a lot of data analysis is going on as to what we have done. There are many things that we have learned which will help improve the monsoon forecast, but it will take about 5 to 10 years to get there. Because the first thing we have to do is analyze the data, we have to get our results published, we have to make suggestions for the models, we have to try those suggestions and develop the models and see which way does it help, what are the factors it influences, and then get to the operational side where these effects can then begin to impact the monsoon forecast. So we did some very interesting studies on the way. Here I'm showing you results from an ocean model. Essentially, some of this is looking like a bulge in the sea, some of this is looking like a dip in the sea. This is exaggerated. The biggest bulge to biggest dip is only about 30 or 40 centimeters. But we understand this very well. What we don't understand very well is how the fresh water from the river and the salty water from the south of bay get stirred and mixed together, because that makes a big difference in how the heat is spread. So I'm going to go over this. So essentially there are going to be three major things that will happen as part of our 5-year project. We have established a long-term observatory, which is in the North Bay of Bengal, which will tell us how the air and sea talk to each other. We will be able to test our models and figure out where the models are going wrong in terms of the monsoon prediction. And that depends a whole lot on what the ocean is doing and how it's trapping the heat. We have measured how the churning in the ocean happens. On a physical level, we have measured how the mixing is happening. It turns out that our numerical models are churning the ocean a little too much, and the real ocean actually does not churn as much, but it churns in different places than where the numerical models do. So now we are beginning to understand that from the data we have. And then we are also beginning to look at the smaller scale processes, which is one of the things that my lab does, is to figure out how and why this is happening and how we can use that to basically fix the models, which will then eventually lead to better predictions. So I told you when we are on the ship, we have, we have work going on in the ship 24 hours a day. And the way we do it is that everybody is supposed to work for 12 hours. So when I was on the ship, I would work from 3 a.m. to 3 p.m. Then the next shift would come and they would work from 3 p.m. to 3 a.m. And in between you relieve each other for, you have to go have breakfast or lunch or food or take a short break, that is fine. But everybody pretty much works 12 hours a day. So when my shift would end at 3 p.m., I would need some sort of a rest and some, getting away from all the data collection and all the work that was going on. So then the first couple of days, it turns out that the US ship has some 7 or 8 yoga mats. So you can go and bring one out, you can go on the deck of the ship. So the first day or two I started doing yoga by myself. I would do some yoga poses and sit down. On the second day, 3 more people joined me, and then by third day it turned out that some of the people who had joined me actually had been practicing yoga for much longer than I had. And so one of the students, actually, she was a graduate student from Oregon State. She had been doing yoga since she was 5 or maybe 3 or something, because her mom was teaching yoga in Oregon. So then, I told her that she had to lead the yoga practice. So as much as the weather permitted, on every day afternoon from after the 3 p.m. shift ended, if it there was a saying on the ship, if it is 4 p.m. it must be yoga time, because we would have yoga from 4 to 5, and then at 5 we would then go for dinner, and then by 6:30 or 7 I had to go to bed, because then I had to wake up at 2 a.m. to get ready for my 3 a.m. shift, and which is what was happening with a lot of people. And then with time, the ship's crew also started joining us. So this was one of the people from the ship's crew. Here, this is on a day where a lot of people are actually on work, so there's only 5 of us. I think the maximum we had was about 15 people on the deck doing yoga together. So that was quite something. But I thought I'd show you just this sample of doing yoga on the ship. It's actually really hard to do yoga on the ship, because the winds, the motion of the ship, your yoga mats are flying all over the place, the ship is moving in directions, so it can be fairly hard to maintain your balance. But I can think of no better way to end a 12-hour shift than doing Surya Namaskar and doing the stretches, and then having some contemplative time, some deep meditative time. And it's actually, and by the time you come to this, the sun would be about to set. So this was a very, very interesting experience. Sunrise and sunset from a ship, just amazing. Because when you go on a ship, then you really realize what it means to be living on a planet which is 3/4 ocean. Because we are 300 miles or 200 miles from the nearest coast, and you see nothing but water all around. And so you might think if you're on a ship for 32 days or 35 days, it might get really boring, because there are many things that prevent it from being boring. So firstly, you're working very hard for 12 hours every day. Secondly, you're really surrounded by nature in its most pristine form. And thirdly, the colors around you are continually changing. Even the water in the ocean doesn't look the same color from hour to hour, from day to day. The skies don't look the same from hour to hour, from day to day. The tropical skies really change a whole lot. You can see all kinds of cloud formation happening. You can see the cloud formation happening at a huge distance. You can actually see the rain move towards you. And if you're on the deck of the ship. If you're working inside the lab, that also happens quite often because you're monitoring a lot of instrumentation inside the lab. You could just monitor the temperature, the air temperature, and if you could see a big dip in the air temperature, you knew that in less than 10 minutes, you'd just be pounded by it. So that would happen every time. So there were many, it was really interesting and eye-opening to work on the ship for a couple of days. So I will stop here, and if you have any questions, I'm happy to take. So we literally studied the physical churning of the ocean as well as the mental churning within ourselves.
The sensors that you deploy into the ocean, what kind of sensors, what does it do?
Very good question. So the sensors we deploy in the ocean measure a lot of the physical properties of the ocean. And the properties that we are most interested in, so I'll just show you some of my toys. Not my toys, but the whole project's sensors that we use. So this was the wood sole mooring that I was showing you that has all sensors going way back quite a bit. What they're measuring is the temperature of the ocean at whatever place they are at. And another thing they're measuring is the conductivity of the water. The conductivity of the water has a direct relationship with how salty the water is. So it turns out that particularly in the northern Indian Ocean, in the Bay of Bengal, it matters a whole lot how much fresh water you have floating on top of the salty water and how salty that water is compared to the rest. Another thing we're using are these sea gliders. What the sea gliders are measuring is, they're also measuring temperature and salinity, but they're measuring it over huge swaths of the ocean. So you let one of these gliders go, it very slowly goes down, and then it very slowly comes up, almost moving at maybe about 4 miles per day. No, this is not. So this is just told. This is where I'm deploying you, and it is given a target position. When it gets to the target position, it comes up and says, where do you want me to go next? And it gets the indication from satellite, and then it goes. Since it moves so slowly, it can be very easily go off course. The currents can move it in different directions. So this comes up maybe 4 or 5 times a day, or about 3 or 4 times a day. And when it comes up, it says, where am I? Am I close to where am I supposed to be? If I'm not, then I will change the direction the next time where I'm going to go, so that I'm closer to where I'm supposed to be. So this is, it's not. So this one that we used, it was going down to about 500 meters, so half a kilometer. For Bay of Bengal, what we are most interested in is the top 100 to top 200 meters. That's plenty. But the reason we send it to 500 meters is because it's better for its batteries. The batteries last longer. We can get data for longer periods. Here is another one which is called a Lagrangian float. This is mainly told we would like you to go to a particular density and then kind of stay there and make measurements and then come up, get the next set of instructions and go down and do this again. And so but these guys are very expensive. We have to pick them back up. We don't leave them out. These guys are relatively expendable because this comes up in a package like this. You basically just throw it overboard, and it self-dissolves into the ocean. And then when it self-dissolves, it has a part which is floating up, and the part which is floating up is sending us data. Sometimes every 5 minutes, later on every half an hour or every hour. And
what kind of data?
So that is sending us the temperature, the surface temperature it's measuring, and the surface salinity is measuring. It turns out the salinity is very expensive to measure, so we have many more of these that measure only the temperature, and then we have few of those that measure the salinity. Then there is a what's called a wire walker that is driven by the surface waves, and this is a special kind of instrument because as it goes up and down, again, we are physicists, so we always are measuring temperature, salinity, but we are also measuring currents. So this mooring is also measuring currents in the water column.
This one is also measuring currents in the water. We can infer, by doing some data analysis, we can figure out how fast the currents are from these instruments.
Okay, good.
And then a lot can be done by a ship. So the ship has a number of instruments that are attached to it. There's usually a chain which has many thermistors, so they are taking temperature measurements. There are acoustic devices which are basically telling us how the currents in the water column are. There are things that we deploy from the back of the ship which go up and down very rapidly, figuring out what the temperature and the salinity are looking like in the top 200 meters or so. So what is currently happening is that we have taken measurements which are 1300. So here's one sample of what we measured in the top 250 meters over 1300 kilometers track. Some details of what is happening in ocean eddies over 200 kilometers, more detail of what is happening over 30 kilometers, and then even more detail of what is happening over 1 kilometer. So there are many places we can sort of zoom in and say what is the effect of this on the monsoons, and then we can zoom out all the way out. And this has never been done in the Bay of Bengal, so that makes it very exciting. Right now what is going on is that we have written up our first set of papers. There are about 22 papers that have been written up both by the US team and the Indian team. I'm one of the guest editors for a special issue that will come out on this work. So there are 6 papers in which I'm involved, so I'm not part of the editorial team of those 6 papers, but all the other papers I'm handling those edits. So those papers are getting near final now, and by July or August of this year, we will have that compilation of papers basically telling us what the basic science we have done and how we can use it for monsoons. But I'll go back to my first slide, because I think ultimately that's what this boils down to, is what is the Amrit for us. I think what is the Amrit for us is the realization that we have to pursue this knowledge, and we have to pursue this knowledge in order to get a much better prediction of monsoon. That picture where I showed you where the scale of the monsoon prediction was very, very low, less than 10%. I think we have to improve that. And by improving that, we make life better for billions of people.
So the temperature in India when it rises in the ocean, there was some parallel law.
There is.
So it is like you're saying, it was 115 degrees and
Yes.
unbearable.
Yes.
When does the water one come in and just
So my zeroth order suspicion is that something like this pattern also happens in the Indian Ocean. It's not known.
Okay.
There may be a leak. So if this happened in April, there may be let's say a 20-day or a 25-day lag time where some part of the ocean may have warmed up, let's say about 3 weeks ago. And the conditions were just right. There were no storms, so that trapped a lot of heat, and that heat basically made its way into what I would call this a heat wave. This was like an April heat wave. Normally in India we think of heat waves as happening in May and June. We don't think of heat waves in April. But what has happened this year is that we got a fairly strong heat wave in this part of the world. I think the other thing that is going to happen is, can we now predict when the first wave of monsoon waves will come through? So now what we're doing is we are saying, okay, this is all good. We have now figured out how much the ocean is trapping heat. We are now working towards the next 5-year plan, which is to understand how the variability in these monsoon patterns are. So we are very, very much in the planning phase, and if everything goes well, if we have the blessings, then we will be working on that from 2017 to 2020.
The students from IIT and other institutes,
Right.
they're not on board, but are they working with you to analyze?
No, they are also on board. They are also on board. So this is Abhishek. He did his PhD at ISRO at SAC Ahmedabad. He is He was supposed to come to Oregon, but he's not able to come. But he was on the US ship with us. This is another student. She's from NIO Vizag, Vishakhapatnam. So she's doing her PhD. She was with us. These two are students from Oregon State University. This is a junior scientist from NIOT in Chennai. So when we go, we take the students with us. Yeah, it's senior scientists, it's postdocs, it's graduate students, technicians, and lots and lots of gear. Essentially, things get packed up. Our instrumentation gets packed up 3 months in advance, then it gets shipped to Chennai. Then in Chennai it has to clear customs, and then it has to get, or actually in this particular case we had it shipped to another port, and then it got onto the US vessel. The Indian vessel had a number of their own instrumentation that got on board in Chennai. And then all the US scientists, they fly from here to Chennai. We have to get there about 5 days in advance, because again, after we get to Chennai, we have to clear the Ministry of Home Affairs clearances. We have to make sure we have what's called the FRRO or foreign or something clearance. And once we have that clearance, then we can get on to the US ship, and then we can go out. And all the work that we do, all happens in international waters. We don't do any work in India's EEZ. So all the work that you're seeing in those ships is happening away. So there's some part here which is 200 miles from the coast. We don't work there. We do our work in the Central Bay and about this spot here, where we are more than 200 miles away from the coast.
And you'll be using the same two ships for the next 5 years?
So there are some our basic tool set will get added on with some extra things. So now what we would like. So there's a question between what you would like to have and what we will ultimately have. So I can tell you my wish list. So my wish list is to have again these 2 ships plus the kayak, which like 3 ships, because that gives us a very, very fine picture of what is happening in the upper ocean. That is not available in any other part of the world. The most we've had before this is 2 ships working together in the North Atlantic. That was in 2011 and 2012 when I was part of that. So, of course I would like to have 3 ships again if that's possible, meaning 2 ships and the kayak. I don't know whether that will be possible, because again, in Indian mythology you say the stars have to be aligned just right. So I don't know if the stars will align themselves, but if the stars align themselves, then maybe we'll have 3 ships in one. So that's on the wish list. You saw that one mooring that I showed you from Woods Hole Oceanographic Institution. That mooring was a very valuable piece of equipment. It costs about $1 million, but it is every bit it's worth in terms of money for the data and for the high accuracy and precision data that it gives us about atmosphere motion talking to each other. That was placed about here at 80 north, 90 east. But that was just one mover. In my wish list, I would have one more here, another one here. Or maybe if we could, I could have one here, and one here, because we want to see how these rain patterns, these rain lines move over. Some of that is possible from satellites. Satellites tell you a little bit about where the clouds are, and you can measure the cloud top temperatures, and you can figure out at what height they must be. But what the satellites don't tell you is how much water content is in them, what is their vertical extent, and they don't tell you how the ocean and the atmosphere are talking to each other. So if we have these, and of course satellites only measure the top millimeter of the ocean. They know nothing about how much heat is being trapped underneath the ocean. So with these moorings, we can say a whole lot more about how much heat is being trapped underneath the ocean. So that's on the wish list. The other thing that's on the wish list is for us to have some measurements of what the atmospheric conditions are like. So on this, when we went out there last year and even 2 years before that, all the atmospheric measurements we could make from the ship we did. But it would be nice if, for example, the Indian Meteorological Department, IMD, could release some of their special weather balloons exactly at the same time that we are making measurements, because then they can tell us this is what the state of the atmosphere looks like at the time that we are making measurements. There's an Indian Institute of Tropical Meteorology in Pune. I want them to be involved because they can tell us what their, they can make some extra measurements when we are out there, and that would really bring the atmosphere and the ocean together. Because right now what brings the atmosphere and the ocean together are the moorings and the ships. But we would like to have a state of the atmosphere all over the Indian subcontinent. And so that's on the wish list as well. So now we have to, we hopefully will get more blessings from these other institutions. So the two institutions I mentioned, the Indian Meteorological Department and also the Indian Institute of Tropical Meteorology in Pune. These are 2 or 3 institutions that make cloud measurements. They fly airplanes through clouds. So if they make their measurements at the same time as we are making ours, then I think we can put our heads together and get much farther. But again, there are, anytime you want to do something like this, there are, so many hurdles to be crossed. So I don't know.
Organizing.
It is a lot of organizing, but it is and it is, there are some days that my wife thinks that I've completely abandoned the family with her, but
that's okay. The reward is delayed.
but she knows also how important this is.
And where is she? Where is your home base? Here?
So my home base is here. I'm here at the University of Massachusetts in Dartmouth. I'm at UMass. I did mechanical engineering there, and also I have a joint appointment with the School of Marine Science. And then I have an adjunct appointment with the Woods Oceanographic Institution, which is about an hour towards the Cape. So I'm also working with this one.
Quick question. Marine biology, marine and biology. You touched a little bit on that.
So I didn't, but the team is quite big, as I showed you. There are 50 people, right? So there are some people who are very much interested in the optical properties of the ocean. As how deep does the sun's light go? How does it get absorbed? And how do the animals get to use it? There are people who are very interested in what the marine phytoplankton are. These are essentially single cell. Think of them as single cell plants. They are which are carrying out photosynthesis in the ocean. So there are other scientists who are measuring things like phytoplankton. There are other scientists who are measuring who eats the phytoplankton. So those are zooplankton. So how can we measure zooplankton? Well, let's go out and measure it. In one of our cruises, we also had 3 expert watchers who watch marine mammals, and they do visual inspection. And by visual inspection, they can say what kind of animal it is, how big it is, what kind of class does it belong to. So it turns out that this area around Sri Lanka is very rich in marine mammal population. So we did a census here, and then as they went up north, they also did a marine mammal census, but they didn't find many marine mammals here. Most of them were. So from the biggest marine mammal whales to the smallest phytoplankton, there is a component of that, but I think the biggest or the lowest hanging fruit or the most fruitful part of this collaboration, I think, has to do with the physical part of the monsoon. Of course, the rains affect the marine life, and the marine life, in effect, we talked about how important it is for the farming community here to know when the rains are going to come, with what intensity, how long are they going to last. Similarly, it is very important for all the coastal communities to know, where the fish are, where should I go, what does the health of the fish look like, and what are the factors affecting the fisheries. So the kind of work we're doing also has a very impact. And where will the tropical cyclones form? Because you want to be able to tell the fishermen not to go out in a certain region or what the track of the cyclone is going to be.
So the track of does it go further away towards, say, Australia, and then comes right through Malaysia into the
The tropical storms?
Yeah.
No, you will. So there are some. Some tropical storms will do this, and go through Bangladesh. You know about. I think last year it was category 4 or 5 that made a straight beeline for Vizag, and then basically hit the Vizag port as well as the airport was out and people were affected. But again, knowing that it was coming helped people get prepared. In 2014, when I was coming back after teaching, I got very concerned because there was a Category 4 hurricane that was forming in the bay. About 10 years before that, there was a hurricane that had struck Orissa and about 10,000 people had died.
Is it called hurricane there or 2010?
It is called something, it's called a cyclone. So I forget which cyclone it was. It was about 10,000 deaths in Orissa 10 years before that. 2014, there was like maybe one or two, and then that was not directly related to that cyclone. Because the cyclone track was well predicted, the administration, district administration in the coastal villages moved very fast. They were very effective in getting news out and getting people out. They were very effective in making sure that the fishermen knew about it and were either farther away or had come home. So there were, almost no deaths associated with that. Much difference.
I have a couple of questions. One thing is practical question. Will you get seasick?
That is a very good question, Dr. Singh. So, I do. But it turns out that modern medicine has some wonderful things to offer. So there is a patch one gets that you put in the back of your ear because the skin here is sensitive, and very slowly it absorbs the medicine. What the medicine actually does is it impacts how your eyes and your brain adjust to each other. So the reason you get seasick is because your eyes perceive the world as moving, and your brain tries to adjust for the moving world and keep you in that one form. But if the feedback loop is too fast, then it is forever connecting, and that forever correction basically makes you giddy and makes you feel seasick and you throw up and so on. So what it does is it slows that down, that process down just a little, and the other thing it does is it dilates your pupils just a little. So in order to compensate for that, what I had to do was make the font on my computers or whenever I was working a little bit bigger. And then the other thing I had to do was to make sure that if you're feeling sick, you go out and look at the horizon and get yourself fairly well conditioned. So that medicine worked out quite well because there were some times where the wind conditions got really horrible, and most people even most experienced scientists on the ship were feeling pretty sick. But it so turned out that maybe I only needed to use that medicine the first 3 or 4 days, because after that the body has an adjustment mechanism. So in my case, even though my experienced colleagues kept telling me, okay, now maybe you don't need to put the patch, the first about 15 days I kept putting the patch every 3 days. You have to change the patch every 3 days, because by then all the medicine is absorbed. So after 15 days I said, okay, I have to give this a try. And then for the next 15 days I did not use any patch. It was so fine. So next time I go, I'm going to cut that 15 days down to maybe 10 days or 6 days and see if I do fine with that. Some people though in my team had adverse reaction to those patches. So they could not use those patches because they would either get, hallucinations was the worst case, but in some cases the patch was making them more sick than the seasickness itself. So sometimes they just let the seasickness come, you rest for a day or two, and then you slowly get used to it. Other people use these oral medications which are less effective, but they work.
One is, you said a lot of nice things that you measure, you get amplified image. What exactly you measure?
We are measuring so in the ocean, we are measuring the salt content of the ocean, and we are measuring the heat content of the ocean. So we're measuring the temperature and we're measuring the salinity. In addition to that, we are also measuring which way is the water moving. So we're measuring the velocities of the water column. We are measuring at what depth is the water moving in what way. And we have definite theory to sort of back us up as to then how to use that information to understand what actually is going on. So the most basic measurements we are using are
temperature, conductivity of the water column, which is a proxy for salinity, and we are measuring, well, we are also measuring oxygen in the case. But for physics, we need temperature, salinity, and velocity. The velocities we measure by what are called acoustic Doppler current profilers, which are basically for over short distances, they can measure the backscattering and tell us how fast they want to go.
So the mechanical movement is what then you try and correlate with the.
So then we try to put it in our theories as to what is actually happening, how much. So that those temperature measurements, when we do them, not just over one location, but as the ship is moving over a huge location, then it can tell us over 1,000 kilometers what is the temperature distribution like, what is the heat distribution like. But since we have the measurement every 4 kilometers, we can also look at it in a smaller region and say what is the heat distribution like here. We can go in finer details. Then there are other instruments which can go more in detail. So we can select out some area and say this area is very interesting. Let's just stay in this location for 2 days, 3.5 days. And what we do is do repeated measurements there to look at what is happening at finer scale with all our instruments. So we just, you throw a bunch of instruments there, you just work there until you have a good solid data set that then you can take home. And then once you bring it home, it takes you 2 years to analyze the data set because we have to do that much processing. So that's the base here.
You said that it stores energy. You mean there is just sun energy, or you said eddies that store energy? Is that mechanical energy?
So the eddies have both mechanical energy in terms of their own kinetic energy. You can think of them as sort of whirling masses. But they're also storing thermal energy from the sun. And the thermal energy from the sun, some of it may be direct, but a lot of it is thermal energy that sun put in some regions that then came down and then got trapped. And they got trapped because they were overrun by lighter river water. So now you had some warm salty water which got warmed by the sun. And then but for some reason if the river water now comes and caps over this warm salty water because the river water is lighter, then this warm salty water can now subduct and go deeper. And so now what you've done is you've essentially created a natural battery of sorts, natural storage of thermal energy of sorts. And when the conditions are right, when the winds pick up, the next time a storm is brewing, that storm can now, in other parts of the world, the situation is completely different. If I was in the mid-latitude North Atlantic, and if a storm comes, and if the storm tries to get energy from the ocean, it can get some energy from the top part of the ocean. That's how the Gulf of Mexico storms or the storms off the Caribbean amplify. But as they come further up north, even if they try to churn the ocean, what they get is cold water. So that cold water essentially cuts off their energy supply, and that's how they die out. In this region, the story is quite different because now the eddies have trapped up this thermal energy. Now if a hurricane is going over it, if it churns the water, what it can get is rather than weakening, because of the churning of the ocean, it can get this extra energy boost if there happens to be this thermal energy, this battery, this natural battery that is storing thermal energy. So now instead of the hurricane decaying, it may even intensify more, but that completely depends on what the subsurface ocean is doing. If the subsurface ocean does not have this hot water patch, then it will essentially decay in intensity. So we know the track of the cyclonic storms quite well. What we don't know is the intensity. And the intensity to a great deal depends on how much heat, how much thermal energy is stored. And that ultimately depends on what the ocean is.
Excuse me, thank you very much. I really appreciate it. Enjoy it very much.
Thank you very much. I this story about some of the Manthan and any connection with this, because there is I'm not sure if you have paid attention to this since you have time maybe over the set, maybe you can look up about this. There is you see the thing that you mentioned is thermal energy or sun energy or even mechanical energy, and then water, the air. He also said the space has some how far it will go. And this all other contributors. There are a lot of puranic stories, how they interact these. And you may conceptually think about all your measurements, but also the characters of these five elements. The five elements are in Ayurveda, they are described a little bit differently than even the word. So that they are devas. There is the Vayu Devta.
Right.
Varun
Varun
Devta.
Devta is Vayu.
Exactly. And they all have their, it's a very interesting thing. I don't know that much, I only know a little bit from what I see on TV. But there is a very subtle interactions between them and among them. And this, since you mentioned about this yearning, how that is all connected to everything else. I always get very fascinated with that because the system works. Even whatever the system they have of prediction. I went to a Rashtriya Sanskrit Sansthan in Delhi, and there was a professor there who told me that they can, he said that we can even go beyond 7-10 days, but they predict 2 years ago before. And I don't know how true it is, but he said that 70% accuracy. Now 70% accuracy is pretty strong. If you were, of course, they probably are using the seasons of
it depends on what is it that they are predicting. I'm talking specifically about when will the next big rain event come, and when will the next break event come, which means possibly a rain or very, very little rain or not rain.
Yeah, well, I mean, as you know, that they calculate down the grahas and other things, and they say that I think they go by days also. But I can understand if they predict 2 years from now, obviously they have the statistical data. They know in this month this kind of rain.
Right. No, so I think that even the statistical predictions even IMD was doing. Yes. So what the statistical predictions will tell you is what is the probability of rain in June or July or August. I think that even farmers know at the back of their head. They know that if this is a particular mark, whatever day of the mark, and this is how much I can expect, and I can expect. If the conditions are normal, then I expect more or less rain. What we are after is more accuracy. I mean, what we want to be able to tell is 2 weeks in advance. Can you say what is going to happen 2 weeks from now? Because that, all kinds of logistics things. You can think of farming, you can think of transport, you can think of agriculture, you can think of economy, you can think of where to send water and where not to send water, where to send goods, where not to send goods.
Yeah, what I think I was trying to lead to is that whatever they use, they may be as accurate or maybe less or more than you, which is okay, but they use a system that you can learn about the system. I mean, see, what I'm trying to say, first I said these 5 elements, and then I said that they use these elements to say something. So then, by knowing that how they use, what kind of forces they use, we can learn more about those elements to use it here.
To connect it.
And then you may have, I found at least in chemistry, the concepts are very important. The kind of framework you develop is from the concept. The more you know about the concept, the better framework you can, resolution and other things you can develop. So, I think one of the things that is very rich in India is this cultural custom that they have of memory. People have culturally remembered a lot of things, and then they have documented, put them in some mathematics or whatever. Their calculations not obviously measured. That's why I asked you what exactly you measured. And so they also measuring something. The power of Vayu or the Agni, who is more powerful, who is less powerful. I mean, that kind of the weightage that you may be able to find and may be useful. Because obviously these people didn't do all these movies and all that, but they had something else. They were learning that. We can learn something more about that those conceptually that might become in your, I mean, just a thing, because if you are familiar, the Western scientists probably will not delve into that, and they may not appreciate it. They might just think that's all. I mean, even Indian scientist probably would say the same thing. But the point is that as a true scientist, you're really interested in getting whatever information you can get from wherever.
Yes.
And I found actually in chemistry it is very useful. A lot of information that is in Indian, obviously I use Ayurveda, medical, or herbal, that kind of stuff. I find them to be very useful and very practical. But their principles are not the same as these, right? So I can learn more about those principles and maybe mix it with whatever we know today, and that might be very helpful. So I think it maybe it's worthwhile to do that.
Some reading is required.
Some reading is required, yeah. And you have to find some interesting stories. They're all about the stories. You know, I have been I've been watching, and it's very slow. There is a serial called Mahabali Hanuman.
Right.
That's where I thought about it more, because it's like Hanuman's character. It's not just simply like he just went to Lanka and he did this. Actually, it's very deep. It's all maybe just imagination. It may be just a story. Maybe nothing true, or maybe some true and then a lot of imagination. But the stories are all so connected, and then you really get to see. I always try to see it from these different forces, and they are really, when you say that these devas and asuras and suras, they were doing this, what does that really mean? I mean, you said that it's positive and negative, or good and bad in us, which is true. But then knowing that how they deal with it, we also know that in what direction should we be. I mean, if you really have bad habits, then you don't want to be on the side of the fire. Oh no, you want to be put that on the side of fire, because that will help you remove. You don't want your good thing to be on down the line first, because if the good things are gone, then you're really not left with much, or if you're confused. So there's a conceptual thing one could try to have, and I found that I mean you can it's available online, so I don't watch on TV. It's too slow and too much commercial. I just watch it on online one, which is much faster. And I can watch whenever I want to watch. And I'm just interested in learning about this character, Hanuman character, what it is, what it represents. There is a mixture of it's a Kesari Nanda, Nanjani, Nanjani, Monsoon also, and Sankar Suman also. What does that all really mean? These are all different kind of forces. And then when these forces combine, they create something that is more powerful. It is something like you're doing some modeling, salinity and thermal energy and mechanical energy, and all that really combines eventually brings rain. Well, I think last question I want to ask you is that you said there is the rain sometimes there also. When the rain occurs, is there a difference in the measurements?
Yes. So the physical properties also change when the rain.
As the rain occurs.
As the rain occurs, because the temperature of the atmosphere changes. And we do measure the rain itself, but we also can see the impact of the rain on the other variables.
Yeah.
And I wish I could bring up some of the photographs. So what I did was, when I was off duty and when the rain occurs, the character of the sea surface completely changes depending on the size of the raindrop. So sometimes you can come out on the deck and you look out on the surface of the deck. You think that you are looking at a desert. Rain ke टीले होते हैं ना, you're looking at the mounds of desert, because the small waves have all died out. All you see are big waves, and you see raindrops falling on that. Because what the raindrops have done is they've dampened out the smallest of the waves, and only the big waves are. So it almost seems as if you're looking out at rain in a desert, which is falling on the mounds of earth. There are other times when it's raining very heavily on one side of the ship, you can see, and on the other side of the ship it's sunny. And so that gives you a completely different picture, and gives you an appreciation for how localized these events can be.
Yeah, I'll be interested to know what those changes are. I mean, in depth, quantitatively, as to what is the extent of changes that you see. Like you're saying that if you have a big drop change,
the size of the raindrops matters. The size of the raindrops matters, and how it forms pools on the surface of the ocean and how it mixes up.
how salty does the seawater get because of the rain, or how fresh, how less salty, how fresh does it get, and how does that spread in the vertical and also in the horizontal. The spread in the vertical is important because that tells us if you put a lot of fresh water layer up on top, then the sun can still penetrate deeper. But even if the sun warms up some layer underneath, it still doesn't get so light that it will break through this fresh water. So that's one of the mechanisms by which you actually trap the heat. So there is an interplay between the rain and the trapping of the heat. Like you were saying, that so now I have to go back and see what is the competition between Varun and Agni. What is the competition? So Indra had to do with the rain. So the relationship between Indra and Surya, the relationship between Varun and Agni is
very important. Actually, I'm pretty sure because these characters descriptions are so detailed and so in a very very subtle way also. And every subtlety is mentioned. And when I taught for 14 years a course called Chemistry of the Mind in the chemistry department. And in that process I learned it's really like you were saying, you know, it's you can transform that into some of the Manthan can be internal or external.
Right.
The same way it's up to really the mind. The mind, the way it plays, puts things in whatever perspective it puts, that's how you understand. And it's generally true. Even if you showed this picture to somebody who has no background in any of that, they have their own perspective of whatever it said or whatever color it was, whatever directions he was showing. So everybody makes some sense to it. So these subtle descriptions are their mental projection of what is happening, for their observation. We didn't have the machines, probably didn't need it. You know, some people still, when if you are good at cooking, then you really don't use a recipe. You kind of have your own sense. So what you are doing is you probably do everything by recipe because we are like you want to make sure that we don't know. But for somebody else, like you know the people who are who go to ocean quite often, or the tribal people who know how to see the signs. You know, it's like when the tsunami came in Andaman, there was a tribe which not a single person died because they could see the sense of animal behavior, and then they knew.